Hello, my name is Adlyn Nazurah. My metric number is F1050.
Hello, and my name is Nashwa. My matrix number is F1129.
Hi, my name is Yasmin and my matrix number is F1122.
So today we will talk about the differentiation is the process of finding a function that outputs the rate of change of one variable with respect to another variable. There are numerous applications of derivative in various fields such as engineering, economics, physics, biology, and others. So in this project, we consider a real-world engineering scenario involving vehicle motion. The position of a vehicle over time is modeled by the function of y equal to t cubed minus by 12t squared plus 36t, where t represents time. The objective of this problem is to apply differentiation techniques to analyze the behavior of the function. Specifically, we aim to determine the maximum and minimum points as well as the inflection point using the first and second derivatives. These points are important as they help describe how the motion of the system changes over time and provide insights into real-world engineering applications.
So now, our application of differentiation is, first we start by forming the function, then we find the first derivative, next we set derivative equal to 0 to get the stationary points. After that, we substitute the values back into the original function to find the coordinates. Finally, we use the second derivative test to determine whether the points are maximum or minimum. So now we are going to discuss on mathematical solution with charts and calculation.
Okay.
To solve this problem, we start by differentiating the given function y equals to t cubed minus 12t squared plus 36t to obtain the first derivative, which is y equals to 3t squared minus 24t plus 36. The first derivative is used to find the stationary points by setting it equal to 0 and solving the equation. By factoring, we get in column t minus 2 and another column t minus 6 equals to 0, which give t equals to 2 and t equals to 6 as the stationary points. To find the coordinate of these points, we substitute the values of t back into the original function, resulting in the maximum point at 2, 32 and the minimum point at 6, 0. Next, we find the second derivative, y equals to 6t minus 24, to determine the nature of these points. Substituting t equals to 2 into the second derivative give a negative value indicating a maximum point. substituting t equals to 6 give a positive value indicating a minimum point. So, in conclusion, differentiation is a powerful mathematical tool that can be applied to real-world engineering problems. In this project, we use the first derivative to determine stationary points and the second derivative to classify them as maximum or minimum point, as well as to identify the inflection point. Through the given function, we successfully found the maximum point at 2,32, the minimum point at 6,0, and the inflection point at 4,16. These points help us understand how the behavior of the system changes over time. This demonstrates that differentiation is not only a theoretical concept but also an important method used in engineering to analyze, predict, and optimize system performance.
So that's all from us. Thank you.
Thank you.